Today we're going to talk about oligopoly. An oligopoly, oli means few, and so it's going to be a few firms. You need another one of those?
Never mind, we have it.
So let's review perfect competition. In perfect competition, we have the firms are price takers. The products are identical, like wheat or milk, petroleum, that type of thing. Okay, or like like gas, like they sell at the gas station. That's a good example of perfect competition. Monopoly. Monopoly is a price maker. It's one firm. For example, tap water supplier, cable TV. Monopoly. Imperfect competition. In imperfect competition, we have neither price takers or price makers. Oligopoly is an example of imperfect competition. It's an oligopoly. The firms in an oligopoly are neither price makers or price takers. There are a few firms, and they sell like tennis balls or crude oil, something like that, where a few firms are selling identical or very similar products. All right. Everybody have it? Raise your hand if you're still writing. Okay, we'll move on then. So an oligopoly. Definition. Market structure in which only a few sellers offer similar or identical products. Market structure in which only a few sellers offer similar or identical products. Janesh, you going to take notes? I would strongly advise you to take notes rather than try to remember all this. All right? All right. Everybody have the definition? Interdependence. The actions of one seller have a large impact on the profits of other sellers. A frequent question on oligopolies is, how do you know the firms in this market are an oligopoly? And you can answer that by just a one-term answer. Say they're mutually interdependent. Mutually, all of them are interdependent. Mutually independent. That's what you want to use when they ask you, well, how can you tell this is an oligopoly? You're going to say the firms are mutually interdependent. How are the actions related? Let's say in an oligopoly, one firm produces too much. If one firm produces too much, that's going to cause the price of what they're selling in the market to go down, and all the firms are going to lose money. So the actions of one firm affect the other firms. If a firm produces too little, the other firm's quantity increases and their profit increases. their money that they take in increases. Everybody have it? Oh, looks like. Everybody have it now? All right. Competitive. Firms produce amounts so that all make comparable profits, called collusion. Firms produce amounts that all make comparable profits, called collusion, when they work together or cooperate with each other so that their profits are comparable. That's called collusion. You'd say that's in a competitive market, all the firms are making zero economic profit. Here, all the firms are going to be making comparable profits too. They collude. Collusion is an agreement among firms in a market about quantities to produce and prices to charge. What's going on right now that firms are not colluding? Anybody been paying attention to the news? What's a big issue right now? Yeah.
The gas prices are dropping.
Yeah, oil. The price of oil is going way down because Saudi Arabia is producing a whole bunch. Right? They usually limit. They were limiting how much they produced, and that kept stability in the world market, oil prices in the world market. But Saudi Arabia decided, hey, we're going to put the U.S. companies that are fracking out of business, and by lowering the cost of the oil, and so they're flooding the market with oil, and that's hurting other countries. It's hurting Russia as well. Okay, Russia is largely, their economy is largely dependent on the selling of oil, and so Russia's kind of almost in a recession because of this lower price of oil in the world market, caused by Saudi Arabia not colluding with the other firms, the other countries. Cartel. Group of firms acting in unison or collusion. Can anybody give me an example of a cartel? Yeah, the first thing that comes to mind is drug cartels. And they kind of make their decisions by force. But you could also, what about oil? What is a well-known cartel with oil? Sean? Yeah, OPEC. OPEC stands for oil producing something countries. I can't remember what it stands for, but anyways, OPEC is Arab countries and Venezuela. They used to kind of cooperate and on their quantities and prices, and it pretty much affects the world market for oil. So it's not all the countries in the world that produce oil are in OPEC, but OPEC is a big enough part of it that they can sort of dictate world prices in oil. Okay, so we're going to do a Waterville example. Okay. So that's that first worksheet I gave you. So look at that worksheet and where do you think that where do you think in this Waterville example with Jack and Jill, where do you think that if they collude, if they cooperate with each other, where would they produce in combination? What? You say 60?
Yes.
Yes. Why? How can you tell? Yeah, that's where the revenue is most. So they would each produce 30 and 30. Say they split it down the middle, right? Each would produce 30. So what do you think? So they're producing 30 and they're charging 60. What do you think Jack might do?
Sort of produce a little bit more.
Yeah, Jack may say, "Hey, I can make some more money if I cheat on our agreement and I produce more." So that he sells 40, Jill says still is agreeing with 30, sticking to the agreement with 30. So you can see the overall revenue goes down. What would Jack's revenue be? Here, both their revenues were $1,800. What would his revenue be? He's producing 40 at a price of 50. What would his revenue be?
2,000.
Yeah, so his revenue did go up to 2,000, and Jill's would, because of the lower price, what would Jill's be?
1,500.
Yeah, it'd be 1,500. So she loses out. She was making 1,800. Now she's making 1,500 because he cheated. And it lowered the price of the market. But because he's selling more of a quantity, he's making more, but she's making less. So how's Jill going to respond?
She's going to start eating.
She's going to produce more, right? She'll produce 40 as well, so then they'd be at 80 and 80. I mean 40 and 40, both in combination producing 80. Their total revenue is 3,200. What's their individual revenue? Yeah, 1,600. So are they better off?
No.
By producing more? No. They were making 1,800 apiece when they were cooperating. Now, when they both tried to get ahead or keep up with each other, one tried to get ahead, the other kept up. They're making 1,600. Now, would they cheat again? Would either of them cheat again? Would they go up to? Would one of them produce 50? Why not? Why wouldn't they cheat again? There's a mathematical reason. A mathematical reason. Yeah.
Their profit would decrease to 1,500.
It's not profit. It's revenue.
Or revenue. Yeah.
Yeah, revenue. Even the person that cheated, he's producing. He's producing. If Jack cheated again, he'd be producing 50 at a price of 30. So his revenue would be 1,500. That would be even, and they were at 1,600 apiece. So even by cheating, he's making less than what they were cooperating at 80, right? So they would stick at 80. That's called the Nash equilibrium, right? It's the Nash equilibrium would be 80. It's not the equilibrium, where they would be if they both collude, but if they both try to get ahead and then they realize, hey, we got to. So I need to go back and pick up this. So I didn't get this recorded. We've got the Waterville example. Both firms would produce 40 and 40. That's the Nash equilibrium. And it's a situation in which economic actors interacting with one another each choose their best strategy given the strategies that the other actors have chosen when they're acting in self-interest. That's Nash equilibrium. So they're trying to get ahead when they reach the Nash equilibrium. The result of them trying to get ahead is they reach Nash equilibrium. Let's go back to the overhead, and we can look at this this process we went through when we looked at Jack and Jill's decision. You can make what's called a decision box, and you need to be able to read and even create a decision box for a situation. This tells us. So we started out, so with Jack, we read Jack across and we read Jill up and down. So we started out, they were both selling 30 gallons, right? So Jack and Jill sell 30, their profit, Aid calls it profit, I would say it's revenue, unless it's a zero cost thing, but their profit is $1,800 when they're at 30 and 30. Then we can see Jack would sell 40, that moves us to this column. And Jill was still selling 30, so that's when Jack got 2,000 and Jill got 1,500. That put us in that decision box. And then when Jill responded, that would move her into this row, and we're in this column, that would put us in this box. That's when they were both making $1,600 profit. That's the Nash equilibrium. Okay, and then we're going to talk about dominant strategies and things like that you can determine from a decision box. Now, it'd gone the other way if they were at 30-30 and Jill cheated first, that would move us into this box. Here, in this box, Jack's selling 30 and Jill's selling 40. She would make more. Everybody kind of understand the decision box? All right. So in summary, the quantity produced by a monopoly is less than the quantity produced by an oligopoly, which is less than the quantity produced by perfect competition, which is the socially efficient level. Everybody have that? All right. So the other thing we can summarize is in the price of perfect competition, which is equal to marginal cost, that's going to be the price of the competitive market. It's going to be less than the price of an oligopoly, which is going to be less than the price of a monopoly. As the number of firms in an oligopoly increases, the price approaches the marginal cost like the competitive market. The more firms that are in an oligopoly, the more it will be like the competitive market. Everybody have it? Okay. Game theory. Game theory is a study of how people behave in strategic situations. Right? Anybody heard of John Nash? Anybody seen the movie A Beautiful Mind? Nobody seen it? You've seen it? Yeah. Well, anyways, it was a movie about the guy that came up with game theory. He won a Nobel Prize in economics for game theory. All right. So yeah, that's where game theory came from. Prisoner's Dilemma is an important game that shows why it's difficult to cooperate even when it is mutually beneficial. Everybody has seen the cop shows on TV where they arrest a couple guys that committed a crime, they put them in different rooms, and they try to get them to tell on each other, right? So that's kind of what Prisoner's Dilemma is all about. Let's do an example of Bonnie and Clyde. Okay? So we've got Bonnie and Clyde. Got it now? All right. So with Bonnie and Clyde, Prisoner's Dilemma. Everybody know who Bonnie and Clyde were? Okay, there's a movie about Bonnie and Clyde. They went on a crime spree and killed some people and robbed some banks, and they finally got caught in Texas. The Texas Rangers shot them up. So anyway. But Bonnie and Clyde, so they arrest Bonnie and Clyde. Let's say they didn't get shot. They arrested them. Okay? So this tells their prisoner's dilemma. Before they got arrested, they said, well, if we get caught, we're not going to squeal on each other, right? We're just going to stay silent, not give them any information. Okay? So that would be this decision. Bonnie remains silent and Clyde remains silent. If they both remain silent, they get 1 year each, right? But Bonnie, she's intimidated by the police, and she decides, well, I don't want to. The police tell her, well, we can. If you tell on Clyde, you aren't going to have to go to jail. That sounds pretty good to Bonnie. So if Bonnie confesses. Well, she's trying to think. What this is Bonnie. She's thinking, well, I'm trying to think what Clyde's going to do. So she thinks, if Clyde, so Bonnie is okay. We're reading Bonnie across. Okay, so Bonnie, if Clyde remains silent and she remains silent, then they'll each do 1 year. But she thinks. Bonnie thinks, well, Clyde is probably going to confess, right? and I would get 20 years, and he's going to go free, right? So that wouldn't be a good situation. But if Clyde remains silent, and Bonnie could confess, she's going to go free. Clyde would get 20 years. So she's thinking about what's the best situation for her. So, you know, she knows if she doesn't confess, there's a chance she's going to get 20 years, right? She didn't know because Clyde may confess. So she's probably going to confess, and they're going to end up here, right? And Clyde's going to have the same logic, right? He's going to be thinking, well, I could not trust Bonnie and remain silent. We both get 1 year. But if I remain silent, so that put us in the bottom row, and Bonnie confesses, she's going to go free, and I'm going to get 20 years. So I better confess too, and that would put them in this box, 8 and 8. That's the Nash equilibrium, right? They're both pursuing a dominant strategy, which we'll talk about in a second. But that's the game of prisoner's dilemma. Any questions? All right. So they're both going to pursue to their advantage, which is when they pursue to their advantage, that's the dominant strategy. No matter what, for Bonnie, when you look at these boxes, no matter what Clyde does, if Clyde confesses, it's better for her to confess. She get 8 years versus 20 years. If Clyde remains silent and she confesses, she'd go free, and he'd get or versus remaining silent and get a year. So her advantage is to confess. Same thing, same logic with Clyde, only your arrows are pointing up. Okay, so let's go back to the Bonnie and Clyde. So they chose the dominant strategy. The dominant strategy for both is to confess, and let's define dominant strategy. Dominant strategy is a strategy that is best for a player in a game regardless of the strategies chosen by the other players. Okay, I just talked about all that. It's a strategy that's best for a player in the game regardless of the strategies chosen by the other players. All right, everybody have it? Okay. If both players have a dominant strategy and choose it, Nash equilibrium is reached. All right. So if both players pursue a dominant strategy, they're going to reach Nash equilibrium. There are some cases where they both don't have a dominant strategy. One may have a dominant strategy and the other doesn't. And we'll do examples, an example or two to show you when that case is. That's probably the kind of decision box they would put on the AP exam. Both pursuing a dominant strategy is pretty easy to determine Nash equilibrium. But if one has a dominant strategy and the other doesn't, then you have to think a little bit more about it. Oligopolies pursue their best interest, which is the dominant strategy. All right, everybody have that? Lauren got some handouts for you that I passed out. All right. So now let's do another decision box. So you've got this the Iran handout. Let's look at that one. So we've got oil production. All right. So what you want to do is check to see if anybody has a dominant strategy. So how to read this is so like Iraq. Iraq is a cross. So you look at the first row for Iraq. They can get 40 billion or they could get 30 billion. That favors the 40 billion. So the arrow, we could draw an arrow that direction, right? Then we could do the bottom row. Iraq could get 60 billion or 50 billion. That arrow, we would draw an arrow in that direction for Iraq. So what is Iraq's dominant strategy here? High production. This column, they want to be in this column. So they have a dominant strategy of high production. Let's see if Iran has a dominant strategy. Okay? Iran could be getting, in the first column, 30 billion or 40 billion. We want to draw an arrow up. Right? And then Iraq could be 50 billion or Iran could be 50 billion or 60 billion. That's an arrow up. Okay? So what is Iran's dominant strategy? Both arrows are pointing in the same direction. High production. All right. If both arrows point in the same direction, they have it has a dominant strategy. So they both have dominant strategies. So that puts them in which box? If they both pursue their dominant strategy. Yeah, they're both going to end up here, where their arrows are both pointing. Okay, that's how you can identify dominant strategies. All right. So that's where they would end up with high production. Okay. After having prisoner's dilemma many times, firms will collude and get higher profits. So eventually, they get smart. Iran and Iraq eventually stop trying to get ahead. This is hypothetical. It's not really the situation there is now. But they eventually stop trying to get ahead, and they collude, and they agree on a quantity they're going to produce, and they stick to it, quantity and price. And as a result, they would have the higher profits. If they colluded, they could have had the profits of 50 billion each rather than 40. All right, any questions on that? Everybody think they can evaluate a decision box? Okay. Let's see. That's the notes on oligopoly.